Welcome to the 49th lecture of Digital Electronics subject. In this lecture, we will be dealing an introduction to subtractors and realization of half subtractor using AI logic XOR gate and NAND gate as well as NOR gate. Realization of half subtractor. So coming to an introduction about subtractor. If you have two numbers a and b, and if you need to find a minus b, you find the complement of b and add it to a. So basically, if you are taking in this format, subtractor becomes an adder itself. So that is a basic introduction to an subtractor. So basically, subtractor is an adder itself, provided that you are adding with the complement of the b part. So this is subtrahend and this is minuend. Having subtrahend and b is known as minuend. So here what happens is that subtrahend is added to complement of minuend. So in that concept, subtractor is basically adder itself. So coming into half subtractor, coming to half subtractor. Okay. Half subtractor is basically a 2-bit subtractor. Okay. So here you are having 2 bits a and b, and you will get the result as a minus b. So in the result, you will have difference. In the result, you have difference and borrow. Okay, or you can write as d and b. Now, if you are dealing to some basic principles of this half subtractor, 0 minus 0, that is 0. Then 1 minus 0. 1 minus 0 is 1. 0 minus 1 is 1 with a borrow 1. So this is the difference and this is the borrow. Then 1 minus 1. 1 minus 1 is 0. So in all other cases, borrow becomes 0. Okay. So that is basically the half subtractor. So coming into the truth table of half subtractor. Truth table of half subtractor. We're having two inputs. Inputs are a and b. Outputs are difference d and b. B is borrow. So 0 0 0 1 1 0 and 1 1. 0 minus 0, difference is 0, borrow is 0. 0 minus 1. 0 minus 1, difference is 1 with a borrow 1. 1 minus 0, difference is 1, borrow 0. 1 minus 1 is 0 with the borrow 0. Therefore, we can write difference as. So, if you are writing the decimal equivalence, corresponding to the inputs 0, 1, 2 and 3 in min-term form. In min-term form, difference or d can be written as, so here you will get 0 1. D can be written as so take these two terms, that is sigma m 192, and borrow you can write it as sigma m of 1. That is in min-term form. And in match-term form, you can write it as difference is pi m 0 and 3. So d you can write it as pi m 0 and 3, and borrow as pi m 0 2 3. Pi m 0 2 3. So this is basically you can realize it using a two variable K-map if required. Okay, because you have to pre only, so you can realize it using a two variable K-map. Now coming into the expression of D, expression of difference and borrow, this D and B. So what is D? Sigma m 1 2, that is you can get it as A bar B or A B bar. So D you will get it as A bar B or A B bar. That is again an XOR gate, that is A XOR B. Now coming to what is borrow. Borrow you will get it as A bar B. Borrow you will get it as A bar B. Okay. So these two you can consider it as in sum of product form. Okay. Now if you are drawing using the XOR gate, so realizing using XOR gate, you can realize it like this. You are having A is there, B is there. So A XOR B. Okay. So here you will get D. What is D? D is A XOR B. What is B? B is A bar B. So if I am having A bar, A bar and B. So this you will get it as borrow, and you can connect, if you need, you can connect a NOT gate to A bar. Okay. So that is B. Okay. So this is realization using XOR gate. Next one is realization using AOI gate and or in AOI logic. Here what we can do is that A bar B or A B bar. So A is there. Similarly A bar is there. A bar. B is there. B bar is there. Yeah. First one is A bar B. A bar is there. B is there. A bar B and or A B bar. So A is here. B bar is here. So this is. So you will get A B bar. You or that two. Or that two. You will get a difference D. What is borrow? Borrow is A bar B. Borrow is A bar B. So you can take this part. That is borrow. So you need to have additional gates for this borrow. So that is a realization using AND or invert logic. Next one is a realization of half subtractor using NAND gates only or universal logic, that is NAND gates only. Okay. So here what is the difference? Difference you are getting it as A bar B or A B bar, right? Okay. This A bar B or A B bar. Similarly, borrow you are getting it as A bar B. Now if you are converting it into, this is basically in SOP forms. This is basically in, difference is basically in SOP form. Now if you are converting it into POS form, how would it be? So it is similar to an XOR gate, but anyway I am drawing it once more. This basically becomes a two variable K-map. Yeah. So we are having A B 0 1 0 1 0 1 2 3. This is A bar A B bar B A bar B. So here you will get 1. Here you will get 1. This one is A B bar. Here you will get 1. And the other values are remaining as 0. Where you need to get POS form. This is 0. So to get the POS form, this is A, this is A bar, this is B, and this is B bar. Therefore, D in POS form, you can write it as A or B and this one A bar or B bar, and A bar or B bar. This we can write as A or B and AB bar. That is by applying De Morgan's law. It is by applying De Morgan's law. Therefore, D you can write it as AB bar or B AB bar. Therefore, what is D bar? D bar you can write it as AB bar or B AB bar the whole bar. That is equal to AB bar the whole bar dot B AB bar the whole bar. Therefore, what is D? D is component of D bar. That is D bar bar. That is AB bar dot B AB bar the whole bar. So this is basically in which form? This is in NAND form. Now coming to the expression of borrow. Borrow is A bar B. So this is for difference. Now coming into borrow part. Okay. So I am drawing a two variable K map. Okay. So A B 0 1 0 1 A bar A B bar B. So 0 1 2 and 3. A bar B. So we will get A bar B. So here we will get 1. All other values we will get it as 0. All other values you are getting it as 0. Now to get the POS form, this is A, this is A bar, B, B bar. So borrow in POS form, you can write it as here which is common. Here B is common, and in these two terms which is common. In these two terms what is common? A bar is common. A bar is common. So this is B and this is A bar. So you can write B as A bar or B, right? A bar or B. So you can write as B is equal to A bar or B. Yeah. So what will it be? If you are writing B bar, what is it? A bar or B the whole bar. What is it? That is A bar dot B bar. Therefore, what is B? So B you can write it as A bar is A itself. So it is A dot B bar the whole bar. Okay. So that is also in NAND form. Yeah, that is also in NAND form. That is also in NAND form. Or can you write it in any other track? A dot B bar the whole bar. Okay. Can you write it in any other track? Borrow. Okay. So this is A dot B bar. Okay. A dot B bar whole bar. Okay. Now let me think of this borrow part only. Let me think of this borrow part only. Now if you are going with this term, see what happens. A is here, but here B is already there. But here you need to take B bar. Okay. But we have A B bar. Okay. So here what happens is that you will get an additional NAND gate. If you are going for this combination A dot B bar, you will get an additional NAND gate. So how to avoid these additional NAND gates? So here I am giving a hint. See, here you are having B bar, here you are having B only. So if you are having AB, you will get one NAND gate. B dot AB, you will get two NAND gates. Now to get B bar, you need to use another NAND gate. So what happens is that the number of NAND gates are increasing. Even though if you are reducing with the help of this K map, the number of NAND gates are increasing. So how to take such a situation? Let me come back to this A bar B. So borrow, you can write it as A bar B. Okay. Now, if you are writing borrow as A bar B, I can write B is equal to A bar B and borrow is equal to A bar B and sorry, it is not A bar B. Yeah, not and. I can write like this: B is equal to one second. Let B is equal to B and A bar or B bar. Okay. So if you are simplifying this, what do I get? You will get A bar B or B bar. B bar is 0. Okay. So it will come back to this first question. So B I am able to write as small b is equal to capital B into A bar or B bar. Okay. Therefore, what we can write? B is equal to B or B bar. B bar is equal to B and A bar or B bar, the whole bar. What is it? What is A bar or B bar the whole bar? That is AB bar. AB bar the whole bar. Okay. That is B bar. Okay. Now what is B? B is B dot AB bar the whole bar and complement of that. That you will get B. So I think you got the logic how to take it. Here I am not going for this logic, because if I am going for this logic, what happens? B is equal to you get what A bar or B. If you are going to realize that, what happens is that B is equal to A bar or B the whole bar. Okay, because I need to realize it using NAND gates. B bar or B the whole bar becomes A bar dot B bar. Okay, what is it? That is A bar is A, so it is A dot B bar the whole bar. Okay, so here what is the problem is you need to get B bar out separately. So if you need to get B bar out separately, that introduces an additional NAND gate into the circuit. So try to minimize the number of NAND gates. So here what I am going with a different logic. So B is equal to A bar or B. So B I can address B as common and B and A bar or B bar, because I can address A bar B or B bar, where B dot B bar is equal to 0. And again, since I need to realize it using NAND gates, so I can address B bar is equal to B and A bar or B bar the whole bar. But what is A bar or B bar? A bar or B bar is AB the whole bar, the bar. Then again complement it, you will get B. So to realize half order using NAND gate, this difference I am getting it as, what is difference? Difference is A dot, this AB bar, AB bar the whole bar dot B AB bar the whole bar and bar of it. Okay, so that is difference. And what is borrow? Borrow is B dot AB bar and complement of that. So that is B. Okay, so what we can see is that this borrow can be taken as a part of this difference. Okay, borrow can be taken as a part of this difference. So to realize it using NAND gate, you are having two inputs, A, B. First I will realize AB bar. So here I am having AB bar, then A dot AB bar. This is A dot AB bar the whole bar. Next one is B dot AB bar the whole bar. Here I am having B dot AB bar. This is B dot AB bar the whole bar. Now if you are NANDing that too, here you will get the difference. So I am getting the difference. So what is B? B is B dot AB bar. So that you are getting here, and take the complement of that. That is using NAND gate. So this is borrow. Okay. So that is the basic realization of half subtractor using NAND gates only. So this is half subtractor using NAND gates only. Okay. Now coming into last part. Next one is realization of half subtractor. Realization of half subtractor using NOR gates only. Okay. So what is the difference? The difference is A bar B or A B bar, and borrow is you are getting it as A bar B, right? Borrow is what? Yeah, borrow is A bar B. Yeah. Okay. So to realize it using NOR gates, again what you have is the POS expression of D. What is it? That is A or B. This is the SOP form of representation. To get the POS form of D, what we have is D is equal to, that is already derived here. What is it? That is A or B and A bar or B bar. This A or B and A bar or B bar. Okay. So what is D bar? D bar is A or B and A bar or B bar, the whole bar. What is it? That is A or B, the whole bar, or A bar or B bar, the whole bar. That is by De Morgan's law. Okay. So what is D? D is D bar bar. That is A or B, the whole bar, or A bar or B bar, the whole bar. Okay, so that is in NOR form. Okay. Now regarding borrow. What is borrow? Borrow is A bar or B. A bar and B. What is it basically? If you are writing it in other form, that is B and A bar or B bar. Okay. So you can write B is equal to, or borrow is equal to, or borrow bar. Borrow bar I can write as B and A bar or B bar, the whole bar. So what is it? That I can write as B bar or A bar or B bar, the whole bar. That is borrow. So again that is B bar. So B is B bar bar. What is it? That is B bar or A bar or B bar, the whole bar. Okay. So that is again in NOR form. Okay. So that is how you are realizing B. Now I am going to realize it using. This one using NOR gates. Okay. So I write difference first. Difference is A or B bar or A bar or B bar, the whole bar. That is difference. And borrow, we can write it as borrow is B bar or A bar or B bar, the whole bar. A bar or B bar, the whole bar. Okay. So both are in NOR forms. Therefore we can write what? We can realize the circuit A, B. First one is A NOR B. First one I can realize it as this one, A NOR A or B, the whole bar. Next one is A bar or next one is A bar or B bar, right? This A or B bar, and next one is A bar or B bar, the whole bar, right? A bar or B bar the whole bar. Okay. So we can have NOR gate. This is A bar. Again, not this one. B bar. If you are NORing that too, so what we get it as A bar or B bar the whole bar. If you are NORing that two elements, you will get D. Now what is B? B bar is NORed with this one. A bar or B bar the whole bar. Okay. You are NORing that two elements and you are getting the boron. Now how many NOR gates are there? You can see that 1, 2, 3, 4, 5, 6. There are 6 NOR gates which is used here. Okay. Now is there any possibility to reduce to less number of NOR gates? That is what I am looking for here. Okay. So that part we will deal in the next lecture. How to reduce number of NOR gates. How to reduce number of NOR gates, that we will deal in the next lecture. Next lecture will be a short lecture to reduce number of NOR gates. Regarding NOR gates only, because NAND gates we have got how many NAND gates? 1, 2, 3, 4 and 5. We have got only 5 NAND gates. So here, since you are getting 6 NOR gates, so here the realization is correct, but the only thing is that you are getting 6 NOR gates. Whether it is possible to realize it using less number of NOR gates, that we are going to deal with in the next lecture. Thank you.